Today we are going to start here in bell work. We're finding the derivative. Technically, we're finding the second derivative, but it doesn't matter. Okay, second derivative, first derivative, who cares? It's the same thing. Okay, just remember d squared x over dy squared just means take the derivative. Okay, on this first one, 1/3, 3x plus 2 to the 6th. If I'm taking the derivative, what special rule are we going to have to do to take the derivative? Chain rule. What looking at that problem tells you, oh yeah, I got to use chain rule here. The parentheses with an exponent, yeah, those two things together are like, okay, yeah, that means chain rule. Okay, so if I'm doing chain rule here, Jesse, what are you going to do here to find chain rule?
You put the 6 times front, get 2.
Good.
And then you rewrite the middle.
Rewrite the baby.
Times 3.
Times, what's my new exponent going to be?
To the 5th.
My new exponent is going to be to the 5th power. He multiplied by his exponent and then subtracted 1 from his exponent. And then he's taking that whole thing and multiplying it by 3 because that is the derivative on the inside. That looks a little funky. We could reduce the 3 and the 1/3. What would happen with the 3 and the 1/3? Cancel. All I'd be left with then is 6 times 3x plus 2 to the 5th. Derivatives. We did that all the time. Let's look at the second one. dy dx equals 2 sine square root of x plus 2. I'm always going to make it a habit that when I see square roots, I just get rid of them right away. I hate square roots so much. Rewrite them as x to 1/2. My brain won't hurt. All right, so there's my setup. We're taking the derivative. So if I'm taking the derivative here, Aiden, what am I going to do? Yep, we're taking the derivative. So 2 is going to stay. The derivative of sine is cosine. Then what? We rewrite the baby, so x to 1/2. One half. Good. Square root of x on bottom, or x to negative 1/2, however you want to write that. Good. That's his derivative. It's plus 2. What's the derivative of plus 2? Nothing. That goes away. So that's our derivative. We could clean this up. If I clean that up, it would be, well, the 2 and the 1/2 would go away. I'd get cosine of the square root of x, or x to 1/2. And that x to 1/2 is negative, so that means it goes on bottom. Gets me that right there. That's easy. We take derivatives. Now, what we're doing here for the next week is we're going to do the opposite of chain rule. We're going to do reverse chain rule because now we're talking about integrals. Okay? Now what we're going to do is we're going to take this guy right here. We are going to find the integral of it, and we got to be able to work it from this guy and go back to there. Okay? We're going to have to take, those two things look similar. Like you can see how we can figure this out from that. We can get to that point. But the other one we got to do is this guy. We got to take the integral of that guy and get it back to that. Those two things don't look the same. They look significantly different. We're going to have to do some work to figure this out. All right. The skill we're learning today is called U-Substitution. It's really important here. It is very much a systematic approach. Think back when you learned like elimination and substitution. There were some very set steps that you had to follow in order to do it. That's what we're doing here as well. It is not a lot of thinking. It is a lot more of I do this, then I do this, then I do this, and we go. See how we can do with it today. Today we're talking about U-Substitution. Okay? It's a weird concept. We're going to go from X's to U's. And the reason we do that is because it makes it easier on your brain. Okay? When we look at this thing initially, you might not be able to see the connection we're making. But if we substitute in the letter U, okay, if we use this substitution for U, we're going to be able to understand the problem a little bit more. It is going to take a couple examples for your brain to figure it out. Okay, so at first glance, when we do it, just follow the pattern. After we've done it a few times, you could start to make the connections. Oh, this is what we're doing, and this is why I'm doing it. Okay, don't be scared. The hardest thing about today is understanding what we should make U. Okay, remember, this is reverse chain rule. This is the opposite of chain rule. And so we often want to pick the thing inside of parentheses. When in doubt, it's the thing inside of parentheses. Okay, things we're going to make U, the highest power of X when there's two different X things. If there's two different X things, pick the one with the higher power. Okay, if we've got natural log, we're going to pick natural log. If we've got multiple e's, we pick the more complicated e. If we've got e with an exponent, pick the exponent. Again, that will make more sense as we go. We'll see it as we do it. Let's try it. Okay, we're finding an indefinite integral, so we don't have any bounds here. We're finding the integral of 6 times 3x plus 2 to the 5th dx. So the first thing we're going to do with this problem is recognize that this is a reverse chain rule problem. What about this problem tells you, oh yeah, I'm going to have to do reverse chain rule here? X inside the parentheses. There's something fancy inside of parentheses, probably a reverse chain rule question. That's what this is. This is a U-sub problem. So in this case, we're going to start off by identifying what we think U is going to be. In this case, the U is the thing inside of the parentheses. So we write that down. The next thing we're going to do is find the derivative of that. What is the derivative of 3x plus 2? It is 3. The derivative of 3x plus 2 is 3. We find the derivative. The next thing we are going to do is we are going to get dx by itself. So u equals du over dx. That's the derivative of u. Okay? So to get to get dx by itself, how do I get it out of the denominator? Multiply both sides by dx. So now I get du equals 3 dx. I am trying to get dx by itself. What else do I need to do to get dx by itself? Divide by 3. Divide by 3. And that seems kind of strange, but you'll understand why here in a second. So now we've got 2 substitutions we're going to make. For 3x plus 2, we are going to plug in the letter u. For dx, we are going to substitute in du over 3. It's 2 different substitutions we're about to make. Okay, so we find this stuff, and then we sub in. Okay, so I'm going to rewrite my integral. It's the integral of 6 u. Because we are substituting in for 3x plus 2, we're going to sub in the letter u. U to the 5th power. And then for dx, we're going to be able to substitute in. What can I substitute in for dx? Du over 3. When I set this problem up, notice that there's no longer an x in the problem. It's just u's. Okay, and it looks kind of strange, but it's going to help us out. The other thing we're always going to do to make life easier is pull out any constants. Are there any constants in this problem? Any just numbers? 6 and 3. I got 6 and a 3. What's 6 divided by 3? 2. We're going to take the constant of 2 and we're going to just write it out in front. We just pulled the constant out. Now that makes this problem a lot easier. Now all I have to do in this problem is integrate u to the 5th. Okay? Don't let it bother you that it says u. Treat it just like it would say x. Okay? What is the antiderivative of u to the 5th? Well, we add 1 to our exponent. What else do I need to do? Divide by my exponent. So it's 2 times 1/6 u to the 6th. I just took an antiderivative and I didn't have bounds. So what else do I need to do? Plus c. Plus c. Because anytime I take the antiderivative, I got to include a plus c if there's no bounds. So what is my final answer? I'm done now. 2 times the 6. What's 2 and 1/6 when I reduce it? 1/3. Now that I'm done, I don't want it to be in terms of u anymore. The reason we made it u is because it made it simpler to find the antiderivative. What can I put back in place of u? 3x plus 2. It's still to the 6th power. And then we're going to just have a plus c at the end. That right there is my answer. It's different, but look at what we did. Look what we started with. Look what we ended with. Let's go back to bell work. Oh yeah, I started with that. I ended with that. It's the same thing. We went from this thing back this direction. That's what we're going to do. Okay, that was the skill set we did. It's a little strange, but once we've done it, it'll start making more sense, and you'll start being able to do it faster too. Questions on the first one? Let's do it again. We look at number 2. I told you what the u was. I'm making it easy on you. Why do you think I chose 4x minus 1? It's what's in the. That's a great way to say it. It's what's in the parentheses, or in this, what's in the square root in this case. Same difference. Okay, it's what's inside. It's the inside. It's reverse chain rule. Okay, that's going to be my u. Find du dx and get dx by itself. We're going to find the derivative. Luke L, what's my derivative here? It's 4. Yeah, the derivative is 4, and then he's going to get dx by itself. And so if he gets dx by itself, he multiplies both sides by dx and divides by 4. So it's du over 4 equals dx. We got to identify the u and then figure out what dx is when we get it by itself. If you can do that in your brain, great. Okay, I'm going to write it out every time because it helps me to process. Once we've made that change, now we're going to substitute in. Okay, so we're going to rewrite this integral. I got a 2 on bottom. What is going to go on top? Square root of u, I'm going to write u to the 1/2 power because we hate square roots. Okay, so we substituted in for u. We plugged in u for 4x minus 1, and then I'm going to multiply this by du over 4. If we did it right, there should no longer be an x in the problem. There's no longer an x. It's all in terms of u. That's what I got to get to. Is there any constants here that I could pull out? 1/8. I got a 2 and a 4. I can take a 1/8 out in front. So do that because it just makes the problem simpler. So now it's 1/8 u to the 1/2 du. Then I'm going to find the antiderivative. Austin, what's the antiderivative of u to the 1/2 power? What's my new exponent going to be? 3/2. And then I have to divide by my exponent. So what else do I need to include here? 2/3. If I'm multiplying by 3, if I raise my power to 3/2, I'm dividing by 3/2. So we multiplied by the reciprocal. It's that times the 1/8 that was already there. What else do I need to do if I'm doing antiderivative? Plus c. I get 2 over 24. So 2 over 24, that would be 1/12. Bless you. 1/12. Something to the 3/2 power plus c. Since I'm done, I do not want u in my answer anymore because I've finished the problem. So what's going to go back there? 4x minus 1, whatever u was. U was 4x minus 1, so 4x minus 1 goes right there. That right there is my answer. If you were doing this problem and you were like, did I do it right? You could always take the derivative of this. If you take the derivative of this, you'll get back what you started with. Questions here? Yes, sir.
Will there ever be a point in which there won't be a c?
If there were bounds, there wouldn't be a c. Okay, so on Monday, we'll do them when there's bounds, like 2 and 3. If there's bounds, there's not a plus c. But if there's not any bounds, it's an indefinite integral, so we have to include a plus c at the end. Good question. Here we go. We're going to skip example 3 because it's kind of repetitive, but we haven't identified u yet. What do you think the u is going to be on example 3? That whole thing inside the parentheses, that whole 7x minus 5 is going to be my u. Let's go to example 4. Okay, we need U-substitution. I can tell that because there's multiple x's. There's something important inside of parentheses. What can I do, or what do you think my u is going to be on this problem? X squared plus 5. The thing inside of the parentheses. Also, if there's more than one x, you want to pick the one that has the higher exponent. So x squared plus 5 is the thing I want to choose here. So my u is going to be x squared plus 5. I then need to figure out what du over dx is. I need to find the derivative. So if I'm finding the derivative here, Luke J, what's my derivative going to be? 2x. Then what do you got to do? Multiply by dx. And then divide by 2x. A lot of the time, it's just like these two things flipping spots. 2x, and that's going to be equal to dx. Everybody with me to that point? Now we are going to substitute in. We're going to substitute in. So it's going to be x. What's going to go next after my x? Just the letter u. You don't have to make it big. It's just the letter u. To the 1/3 power. That's still the 1/3 power. And then instead of dx, I'm going to substitute in what I can plug in for dx, which in this case is this du over 2x. If you did this problem correctly, there should no longer be any x's in it by the time I'm ready to integrate. Right now I have x's and u's. I don't like that. I want there just to be u's. Is there any way I can fix that problem? The x's cancel. If you created the correct u and took the derivative correctly, the whole reason we pick what we pick is that the x's will cancel. So those two x's are going to cancel based on what we set up. Now we can do the rest of this problem. What? Is there any constants I can pull out? Pull that 2 out. So what is it? What am I really pulling out, though? I'm pulling out a half. 1/2 u to the 1/3 du. Go ahead and finish that problem for me. We're finding the antiderivative. Jesse, what's the antiderivative of u to the 1/3 going to get me?
4/3, or 3/4 u to the 4/3.
Good. He added 1 to his exponent to get 4/3, and then he multiplied by the reciprocal to get him 3/4. That thing up there is times 1/2. What else do you got to do since you took the antiderivative? Plus c. Good, because there weren't any bounds. It's plus c. Then we can just simplify this guy. That is going to get me 3 over 8. U, I don't want there to be u. We're going to then substitute back in what u was. U is x squared plus 5. So then we can write that x squared plus 5 back on the inside. That right there is my answer. That is my integral, my antiderivative. Again, if you're not sure if you got the right answer, take the derivative of that, and it will get you what you started with. Questions through 4. Let's keep on right along. Number 5. First thing we got to do on 5 is find my u. I can tell that it's a reverse chain rule problem because of parentheses. Important, multiple x's, something important inside the parentheses. What do we think my u is going to be? 2x squared. Do the problem. All right, we are trying to figure out, Razan, once I took my derivative, du over dx is 4x, then what are you going to do? Yep, I found the derivative, and then... Good, divide by 4x, multiplied by dx, so we flip those two side things. We're to that point right there. Good, now we're substituting in. I'm substituting in for this and that. The thing inside the parentheses and the dx. It is x sine something. And here it's going to be u. Instead of dx, I'm plugging in what dx is. dx is du over 4x. Questions to that point? If I did it right, all of the x's are going to go away. Did I do it right?
Yes, you did.
Yeah. The x right there, that x right there, they're going to cancel. That's what I'm looking for. Do I have any constants? 1/4. So I'm going to pull that 1/4 out in front because that 4 is on bottom. So then all I'm left with is sine u du. All I got to do is find the antiderivative of sine. Zachary, what's the antiderivative of sine going to get me? Negative cosine. Good. So it's negative 1/4 because the antiderivative of sine is negative cosine. U plus c because we found the antiderivative. Again, your answer does not have u in it. We use u to help us through the process. But once we're done in the end, my answer is just going to be this, negative 1/4 cosine. Instead of u, I could plug back in 2x squared plus c. Questions on 4, on whatever number that is, 5. Starting to get a little better, okay? Starting to get a little trickier too, but that's why we practice. All we're doing for like the next 4 days is this. All right, looking at example 6. 6 looks really funky. The first thing I would do is I hate that 4 right there. That just throws me off. I'm going to act like it wasn't there. If that 4 wasn't there, how else could they have written it so it wasn't that weird? On the outside, right? Just like sine squared, you could put that on the outside. Those little numbers on the inside throw us off. I'm going to put it on the outside instead. So if I do that, what do you think my u is going to be based off of this setup? ln of x. I don't want to include that 4th. Okay, if you get over to this part and you start having to do chain rule, you made a mistake. Okay, you don't want to have everything with that. It's just the natural log of x, the thing inside the parentheses. Okay, this gets a little weird. Let's find du over dx. What is the derivative of natural log of x? 1 over x. Get dx by itself. If I get dx by itself, I got to multiply by dx. Boop. What else do I got to do? Multiply by x. It's really like cross multiplying here. It's x du equals dx. Okay, so it's not a fraction this time. Every other one we've done so far has been a fraction. This one's not, and that's totally fine. This is what dx is going to be. That is what u is going to be. So we're going to substitute in here. Sorry. All right, so we're plugging in the integral. Instead of that, I'm plugging in u to the fourth all over x. And instead of dx, I am plugging in x du. If I did it right, when I plug back in, the x's are going to cancel. Is that what happened here? Yeah. I've got an x on top and an x on bottom. That's great. Then I'm left with u to the fourth du. Now we can do that the rest of the way. Finish it. Okay. All right, we're finding the antiderivative as u to the fourth. Michael, what's the antiderivative of u to the fourth going to get me? So I add 1 to my exponent. What's my new exponent going to be? And then I divide by my exponent. So what else is going to be there? 1/5 u to the fifth, and then a plus c. To finish this problem, he's just going to replace the u. If he replaces the u, it is going to give me natural log of x. Boom, there's my answer. Questions there? Chugging right along. Let's try example 7. So example 7 leads us into some other things. Okay, you will get better at identifying the u the more we do. Okay, but the one thing you're looking for, if you have two e's, I've got an e on bottom and e on top, your u needs to be the more complicated e part. All right, so where is it more complicated, on top or bottom? Bottom, and you'll see why we want to make that. But here my u is going to be e to the x plus 1. The reason I pick the denominator, okay, the reason I pick the more complicated one, Evan, what's the derivative of that going to get me?
E to the x times 1.
Yeah, so just e to the x. The derivative of e to the x plus 1 is e to the x. That's why we picked it, because the plus 1 is going to go away anyways. Okay, and then when I plug it back in, it's going to cancel the thing I don't want, which is the other guy, that e to the x. So we took the derivative. We're going to get dx by itself. So multiply by dx, divide by e to the x. So du over e to the x equals dx. We subbing e to the x right there. What's going to go on bottom? U. Sometimes students will want to be like, oh, that has e to the x, so I'll substitute a u on top. No, you only substitute u in for the thing we are trying to get, that we started it with. The reason we picked u is for that bottom part, so that's the only place we substituted in. So just on bottom. But for dx, we can substitute what that is, du over e to the x. See if you can finish that. You might get stuck, but try it anyways. Here we go. We get to this point right here. Max, what'd you do?
I'm not good at explaining.
Yeah. Good. I got that.
Cancel those out.
Those cancel. That's what we wanted. That's the reason why we picked the more complicated one, because when we substitute it back in, the EDX are going to cancel. So now he's got 1 over u, du. So if you'd like to, you could rewrite this as u to the negative 1.
And then, if you add 1 to that, that is natural log.
Yeah, if we add 1, we get u to the 0, and then we would divide by 0. That's bad. Sets off an alarm in my brain. Okay? We don't like dividing by 0. So what are we going to do if we add 1 and we get 0? That is natural log. So this guy right here is going to be the natural log. What else did we say we had to include when we took the natural log, or when we took the antiderivative and got natural log? Absolute value. Absolute values there. So you got to be careful with that. Absolute values. All right. then it's u plus c. Okay, that absolute value right now, you might not be like, that's silly, I don't really need it. You do for the future. Next chapter, you're going to be off if you don't have that. Okay, so the last thing we can do is then substitute what u is, e to the x plus 1 plus c. No. Questions here? Yeah, so du goes away because du represents, like, I found the derivative, right? When I do an integral, I'm getting away with that. I'm going away with it. It's not just going away. It represents kind of like the ending mark of my integral. Like, hey, I'm integrating this part. When I find the antiderivative, it's going to go away. I always think when I take the antiderivative, it becomes my plus c. All right, that becomes my plus c. It gets kind of strange. It's not worth going into a deep discussion. But when I find the antiderivative, that du is going to go away. All right, next one. Example 8, last one. We start off with identifying a u. Any guesses as to what my u is going to be here? It's not going to be cosine square root of x, because think about why. What would be the derivative of cosine? Sine with some stuff. I don't have any signs here. That's not going to cancel with anything, so that would be bad. I need it to cancel with something. It is that thing right there. Because think, if I wrote that, it'd be cosine parentheses square root of x. And so when in doubt, we pick the thing inside the parentheses. Okay, my u is going to be x to the 1/2 power. And we'll see why here in a second. But again, it's x to the 1/2. But it's important, which x to the 1/2 did I want? The top one. I wanted the top one here. Okay, that'll make sense here in a second. Let's find the derivative. Birthday boy, what's my derivative here? Multiply by my exponent.
1/2 x to the 3.
Then subtract 1 from my exponent. Good. 1/2 x to the negative 1/2. It's weird because we're going back and forth in the same problem. You're taking derivatives. You're doing integrals. It'll help you get it straight. Good. That's his derivative. Get dx by itself. Think about that for a second. Get dx by itself. Think about, what does x to the negative 1/2 power mean? Square root of x. And where is it? It's in the denominator. Because if it's x to the negative 1/2, this right here is the same thing as this. 1/2 square root of x. Okay, that's what we're doing. And then to get dx by itself, again, it's like cross multiplying. I'm going to multiply by dx on both sides. And then I would multiply by 2 square root of x du is all equal to dx. It's a little weird. That's why we practice together. That's why we're doing 4 days of it. That way we get good. We're integrating. What can I write on top? Cosine u. What can I write on bottom? Square root of x. Do not substitute in for that. We want that to go away. Okay, we don't want multiple u's in my problem. This is just square root of x. Then what we can do is substitute in what dx is. Dx is 2 square root of x dx. I'm sorry, du. If we did it correctly, my x's should go away. Is that what's happening here? Yeah, the square roots of u's are going to go away. That one is canceling with that one. So we've done it correctly. If they wouldn't have canceled, we made a mistake somewhere. Do we have any constants? 2. So pull that 2 out in front. We're taking the antiderivative of cosine u du. Caden, what's the antiderivative of cosine going to get me? Sine. We can plug in what u is, and it's plus c. My u is going to be the square root of x. That right there is my answer. Look at that answer right there. Think back to bell work. We got that. Look at what we started with in bell work. We started with that. If we work backwards, we got the same thing. Okay? So it looks kind of crazy. We're doing this whole thing with u, but the whole reason we do that is to figure out what's going on. Okay? To work our way backwards. Let's do one more real quick activity here. I'm going to just show you a problem. Based on that problem, all I want you to do is identify u. This isn't in your notes. This is just up on the screen. Okay? So looking at this first problem, or number 2 here. what do you think my u is going to be? The whole inside. If you got multiple letters, pick the one with the higher exponent. If I picked this one right here, what do you think u is going to be? Inside the parentheses. If I picked this one right here, what do you think my u is going to be? Do I want to include the 10? It's just sine x. Okay, the reason, if I put the 10, now I got to do a chain rule. Okay, that's a chain rule thing now. What's the derivative of sine x? Oh, it would be cosine x, which is going to cancel with the other thing. So you got to think, when I take the derivative, I want it to cancel with the other thing. Don't include the exponent there. Okay, again, if you wrote this again, you would be sine x to the 10th. Pick the thing inside the parentheses. On number 7, what do you think my u needs to be? Cosine x, the thing inside of parentheses, the thing being raised to the 5th power. On number 8, what do you think your u needs to be? The whole top. On number 9, what do you think the u needs to be? The one with the bigger exponent. Okay, that guy right there, that's bigger than 3x squared. Okay, because think about it. What would you get if you took the derivative of x cubed plus x squared? The other one, which means when I substitute back in, it's going to cancel. Okay, obviously on number 10, it would be that. On number 11, which one would I want to pick? Sine x, the one on the inside. On number 12, you would pick that one, and so on. Okay, you'll get the feel of it the more we do, but you should be at least somewhat decent now with that.